How did a standard church design from 1883 turn into an engineering riddle so complex that it took humanity 144 years and supersonic aerospace software to solve?
For generations, this project was trapped in a brutal battle against the laws of physics, completely defying all conventional architectural logic.
At the center of this incredible story is a revolutionary, organic monument that engineers of its own era believed could never be built. But on June 10th, 2026, exactly 100 years after its creator's sudden and tragic death, the world watched Pope Leo XIV stand before a massive crowd in Barcelona to officially bless the Tower of Jesus Christ, marking the completion of the tallest church on earth. It looked like a triumphant victory, a historical milestone celebrated. But behind the beautiful lights and the solemn mass lies a dark, mathematical nightmare that took 3 generations of human genius to decode. And now that the modern world has finally solved the physics, a new crisis has begun, threatening to tear a local neighborhood apart. To understand how we got here, we have to look at why this building shouldn't even be standing. The fundamental problem with the Sagrada Familia is rooted in the brutal reality of material limitations. Antoni Gaudí wanted to build a literal mountain of solid stone reaching into the Spanish sky. However, he refused to use the heavy, external flying buttresses that defined traditional Gothic architecture for centuries. This stylistic rebellion created a terrifying engineering paradox. Stone is a material of incredible strength when compressed straight down, but it fails catastrophically when exposed to lateral tension or bending forces. Without massive external walls pushing back, heavy stone buildings naturally crack, warp, and collapse outward under their own immense weight.
Removing these traditional supports, Gaudí left the entire structural mass exposed to forces that should have torn it apart.
This is where the physics stop making sense to the untrained eye. Instead of collapsing outward, the structure stays balanced through an internal matrix of stone. To achieve this, Gaudí had to do something that sounded completely insane to the traditional building world of the 19th century. If he could not use external supports, he had to force the invisible, shifting paths of gravity to stay entirely within the center of the vertical walls. But how do you calculate the exact path of weight, moving through a fluid, highly organic shape that mimics the unpredictable geometry of a dense forest? The answer did not come from mathematical blueprints or standard architectural equations. It came from a strange, complex analog machine built almost entirely by hand. Gaudí spent a decade building a massive funicular model made from hanging strings and thousands of weighted bags filled with birdshot. A hanging string naturally settles into a shape of perfect tension under gravity. If you take that exact shape and flip it upside down, it becomes a catenary curve of perfect compression. By translating these inverted curves into stone, Gaudí found a brilliant way to route enormous downward forces through leaning internal columns.
This meant gravity itself held the building together instead of tearing it apart.
Those soaring, angled columns carried forces so immense that ordinary stone would have shattered under the load. Because of this, the project depended on unusually dense, high-compression basalt rock for its most critical structural points. Even with that solved, the engineering team had barely scratched the surface of the nightmare ahead. Their biggest strength was about to become their greatest vulnerability, because the entire structural logic lived only inside the mind of one man. In 1926, tragedy struck Barcelona. Gaudí was hit by a passing tram and killed, leaving behind an unfinished masterpiece and a lifetime of complex ideas locked away in his mind. He died looking like a beggar, unrecognizable to the people who found him. Then, in 1936, the Spanish Civil War erupted. Anarchists stormed Gaudí's workshop and set it on fire, destroying the majority of his original sketches, notes, and precious plaster models. This is where the real nightmare begins for the generations of architects who followed. They inherited a massive, half-built structure whose geometric secrets had been encoded into hanging strings and broken plaster fragments, with almost no written instructions left to guide them.
Every year of delay meant decades more of agonizing guesswork.
For a long time, it looked as though the central tower crowning the basilica might never be completed. The fragments in the dust were like a jigsaw puzzle with missing pieces. For over 50 years, the world's greatest architects debated whether they should try to finish it or leave it as a ruin to honor a dead genius. The ultimate breakthrough came when modern engineers abandoned traditional construction tools completely. They adopted three-dimensional modeling software, originally developed for the aerospace industry.
The exact same programs used by scientists to design supersonic aircraft wings and complex rocket fuselages.
This software let them digitally reconstruct the shattered plaster fragments recovered from the ashes of the fire. They were able to reverse engineer the hidden mathematical logic Gaudi had worked out using nothing but string and gravity. A century earlier, but discovering the hidden mathematical formula was only half the battle. Turning those digital models into stone threatened to take decades of slow, manual labor on its own. That is what forced construction itself to radically industrialize. The historic site was transformed into something closer to a high-tech manufacturing facility.
Driven by computer-guided CNC machines capable of cutting the hardest stone blocks with millimeter precision in mere hours.
It was a task that once took master stonecutters weeks of grueling work by hand. To assemble these massive pieces safely, hundreds of feet above Barcelona, engineers developed a modular building method, transforming the process into giant Lego blocks. Pre-cut stone panels were assembled off-site, compressed and bound together with internal steel cables, then transported and hoisted into place by massive cranes.
This created a structure rigid enough to withstand earthquakes and the punishing winds of the upper atmosphere.
And that brings us to February 2026, when the final component, a colossal 100-ton ceramic and glass cross, was lifted in sections and locked into place atop the central tower, exactly 172.5 meters above the ground. That number was never an accident. Gaudi designed the central tower to stand exactly 1 meter shorter than the nearby mountain of Montjuic, because he believed no human creation should surpass the work of God. With that final cross in place, the Sagrada Familia officially became the tallest church on the planet. 144 years after the first foundations, stone was laid.
But the story is not finished, and this is the controversial part.
While the central towers are complete, the basilica's main entrance, known as the Glory Facade, is not expected to be finished until around 2034. Standing in its way is a massive problem that no aerospace engineering can solve. Gaudi's original design calls for a monumental, sweeping staircase leading up to that entrance. Building it as planned would require demolishing several residential buildings that now stand exactly where the staircase needs to go. City officials estimate that roughly 200 people currently living in that neighborhood could be permanently displaced from their homes. No final decision has been made, and local residents have been left waiting for answers that never seem to come. So after a century of solving impossible physics, defeating a devastating workshop fire, and reverse engineering a dead man's vision using rocket ship software, the final obstacle, standing between the Sagrada Familia and completion, is not a mathematical mystery. It is a decision about real people living in real homes.
Should a modern city displace an entire neighborhood to finish the vision of an architect who died 100 years ago? Drop your take in the comments and subscribe if you want to keep exploring the edges of what humans can actually build.